All right, today we are going to unlock a really powerful tool for mapping out pretty much any process you can think of, the UML Activity Diagram. I'm talking about anything from a simple workflow to a super complex system. By the end of this, you're going to know exactly how to visualize it all in a way that's, well, crystal clear.
So just think about the last time you used an ATM. It seems simple, right? You pop your card in, you punch in your PIN, and then a whole bunch of stuff happens behind the scenes. How in the world does that machine know what to do if your PIN is right? Or maybe even more importantly, what to do if it's wrong? Well, that precise flow of actions, that's exactly what activity diagrams are built for. And we're going to use that ATM example to walk through this whole thing today.
Okay, first up, modeling the flow of actions. Let's get into the fundamentals. You know, what these diagrams are, why they're so handy, and where they fit in the grand scheme of UML.
So what is an activity diagram really? It's what's called a behavioral diagram in UML. And that word behavioral is super important. It's not about the static parts of a system, the building blocks. No, it's all about the dynamic behavior, the sequence of actions, the flow from one thing to the next. It basically shows you what the system does.
You know, if you're looking at this and thinking, hey, that just looks like a flowchart, you are absolutely on the right track. It really is like a super-powered flowchart. They both want to visualize a process, step by step. But, and this is a big but, activity diagrams have some awesome special features, some real superpowers that let them handle way more complex situations, especially when you've got multiple things happening all at the same time.
All right, let's chart a basic path with our ATM journey. We're going to get practical now and build this thing from scratch, looking at a simple cash withdrawal and learning the core symbols as we go.
Okay, every single process has to start somewhere. In an activity diagram, that's the start node. It's just a simple, solid black circle. Super easy. It's basically a big sign that says, hey, we're starting right here. So from that starting point, the process flows into our first action. These are the actual steps, the things that happen, and we draw them as rectangles with rounded corners. For our ATM, the very first action is, of course, insert card.
And how do we connect these actions? Simple, with control flow arrows. They just show the sequence, the direction of travel. So after you insert the card, the next logical step is to enter PIN. See? We're already building a really clear step-by-step path.
But wait, what if the PIN is wrong? This is where things get really interesting, because real life isn't just a straight line, right? There are choices, there are conditions, different paths you can take. A good diagram has to account for that. So what happens if someone messes up their PIN? Our process needs a plan for that.
And to handle that fork in the road, we use something called a decision node. It's always shown as a diamond shape. Think of a decision node as asking a question that has a simple yes or no answer. In our case, the question is obvious. Is the PIN valid? And just like that, our single path splits into two different branches.
So if the answer is no, if the PIN is invalid, well, that's the end of the road for that attempt. And we show this with an end node. It's a black circle with a border around it. Kind of looks like a bullseye, right? This is the symbol for process over. So wrong PIN, you follow that path, and boom, the transaction is terminated.
All right, section 3, when actions happen at once. We've handled straight lines and we've handled branching paths, but now we get to that superpower I was talking about. What happens when a system needs to do a bunch of things all at the same time? This is where the fork node enters the picture. It's just a thick black bar, but it does something amazing. It splits one flow into several parallel flows. So, once your PIN is validated and you've asked for your cash, the system can kick off multiple tasks simultaneously. The fork node is how we show that moment where everything starts happening at once.
So what are we talking about here? What happens all at once? Well, think about it. As the ATM is physically spitting out your cash, it's also talking to the bank servers to update your balance. And at the same time, it might be sending a transaction notification to your phone. All three of those things, dispensing cash, updating the balance, sending a notification, are happening in parallel. They aren't happening one after another.
Okay, but the transaction isn't truly over until all that stuff is finished, right? You can't get your receipt until the cash is out and the balance is updated. That's the job of the join node. It's another one of those thick black bars, and it's basically the opposite of the fork. It acts as a synchronization point, bringing all those parallel paths back into one single flow. The process literally cannot continue until every single one of those concurrent actions is complete.
Phew, we've covered a ton of ground and a bunch of different symbols. So for this last section, let's make it easy. Here's your diagram cheat sheet, a quick reference to lock in all the key components.
And here it is, the whole toolkit at a glance. You've got your start node to kick things off, your action nodes for the actual steps, connected by the control flow arrows, then the decision node, that diamond, for any conditional branches, the fork node to split into concurrent paths, and the join node to merge them back together, and finally, the end node to show where a flow stops. This is pretty much everything you need to get started.
Okay, one last thing I want to clear up, because this trips people up all the time. The difference between a decision node and a merge node. A decision node, like we saw, takes one path in and splits it into multiple paths based on a condition. Is the pin valid? Yes or no? But what about when a user just has a choice? Like, do you want to withdraw cash or check your balance? Those are two alternative paths. To bring those back together later, you use a merge node. It also uses a diamond shape, but its job is totally different. It just combines multiple alternative flows back into one. So the key takeaway is this: decision splits on a condition. Merge rejoins after a choice.
And that's it. You now have the tools. From making your morning coffee to mapping out a complex workflow at your job, pretty much any process can be diagrammed with these symbols. You've got the basic language to visualize and really understand the flow of actions in any system. So the only question left is, what everyday process are you going to try to diagram next?